So this is the last lecture of this course, and the topic is market and information. In this video, I'm going to overview the structure of this lecture and also review some mathematical background. And the market design is the topic across the lecture 3 and lecture 4. And we wanted to obtain a better outcome by designing a better market. And in lecture 3, we focus matching problems with the complete information in which player's preference is commonly known. And in lecture 5, we are going to focus on auction problem with incomplete information. The main difference between the matching and auction is matching, they cannot use the money to transfer their utility. But in auction, of course, we can use money, and this is a typical example of a transfer utility environment. And we are going to consider incomplete information where players' preference is their own private information. So please have a look at this article, and that introduces some kind of introduction to the auction theory. Lecture 4 has 5 videos except this one. And first we are going to look at the fixed price posting system, which is quite common. And then we are going to study 2 basic auction format, which is a second price auction and the first price auction. And then we are going to study how to maximize the revenue by using a reserve price. And then we are going to discuss how to maximize the welfare to obtain an efficient market. And in tutorial, we are going to discuss some simple example of online marketplace design. So in this lecture, we focus on a very simple cases of 2 buyers, just to get some basic insight. For general cases and for more advanced topics, please have a look at this nice textbook. The main component of this auction theory is information. To deal with incomplete information, it requires some techniques in probability and statistics. A uncertain values is typically viewed as a random variable, and we are going to use some basic mathematical techniques. Those are just high school mathematics, so I'm sure you're already familiar with those things, but I just wanted to remind you of those basic stuff. So, random variable x, we are going to focus on random variable defined on some finite interval 0 and 1. We normalize the lowest value 0 and the highest value 1. The random variable is characterized by a distribution function f, or its density function small f, which is the derivative of this cumulative distribution function. So the probability of that random variable x is smaller than particular number x, small x. That's the f of x. In terms of the density function, that is represented by integration from 0 to that particular x of this density function. And similarly, for the probability of the random variable is greater than a particular number x, that is just 1 minus f of x. And similarly, integrate x to 1. We assume the distribution function f is continuous. That means there is no probability mass. So for any particular number x, it will happen with 0 probability. So the equality doesn't actually matter. So, and some reminder for calculus. So you should be familiar with the integration by parts. Also, you may want to recall the interchanging the order of integration. Sometimes we use the derivative of an inverse function. Of course, it's high school math, so you can review that by yourself. Please also remember the expectation or average of a random variable. That is integration of that random variable with the density function. And conditional expectation is denoted by this notation. So for instance, expect the value of x conditional on x is smaller than particular number x. That is conditioned, and we are going to take this expectation, that is the integration from 0 to x divided by f of x. We know this f of x is the probability of x is smaller than small x. So this product is f x e of x conditional x smaller than particular x. That is this integration. And again, using the integration by parts, we can also represent this into this term. Okay, finally, I would remind you of the order statistics. So for instance, we have two random variables independently drawn from f1 and f2. And sometimes we are interested in the maximum value between an x1 and x2. Of course, that maximum value is also a random variable, and it is drawn from the product of each distribution function. So please make sure you are familiar with those basic skills and techniques before you watch the remaining video.